Okay, will do. Thanks a lot for that. Right, so let's get into this. This is Azure Cosmos DB. I call it Azure Cosmos DB for the SQL professional. So a lot of SQL professionals have obviously heard about Cosmos DB. It's a database. So, what's the difference between SQL Server and Cosmos DB? Well, SQL Server's a relational database. Cosmos DB is a NoSQL database. So it's a bit of a mouthful. It's Microsoft's planet scale, multi-model, geo-redundant, cloud-based database. Sounds a bit like introducing a heavyweight boxer. So let's explore how we can get into Cosmos DB as a SQL DB or dev who already knows probably quite a bit about data and databases in themselves. So quite a lot of terms we'll be familiar with, and quite a lot of terms maybe that are new to us or we've heard before but not explored. So it's born in the cloud. There is an emulator on-prem if you want to play there, save yourself some costs, but it's born in the cloud, not like SQL, it graduated. SQL versus NoSQL. We're going to explore this in quite a bit of detail very, very shortly. Schema on read, schema on write. You might be familiar with those terms. Schema on write is what we do in a SQL database. The schema is already there when we write to it. If the data doesn't match the schema, well, there's an error, we can't write. Schema on read, while we're reading the schema, we're going to read a JSON document. JSON's what Cosmos deals with, and we might not know the schema of that object or that JSON when we read it. All we know is it's JSON, and we're going to infer the schema. Bit of a hierarchy here. Subscriptions, accounts, databases, and containers. In SQL Server, we're used to the the server instance, the databases, the tables, and so on. So touch difference. Multi-models, APIs. We're going to explore multi-models in a little bit of depth very, very shortly. Normalization and denormalization. As a database professional, we're used to normalizing. Well, we might want to denormalize quite a bit in the world of a NoSQL. Backup and restores. This is going to be our third point that we're going to explore, and this might surprise you. Goes hand in hand with recovery models and database consistency. Time to live is an interesting one. We can put a record in Cosmos DB and say we only want it to stay there for 10 minutes, a year, 7 years, whatever it is. And after that period of time, we can set Cosmos to either delete the data or fire an Azure function, do something with it, maybe archive it or do something of our choice. Wouldn't that be great in SQL Server? The unit of currency in Cosmos DB is the resource unit. Obviously, we've got data warehousing units, DTUs, that sort of thing. All the Azure services seem to have their own currency, as it were. Global redundancy, an interesting one, goes hand in hand with the recovery models, the consistency, and the multi-models that we're going to see very soon. And you might be thinking, with multiple databases around the world, what happens if we get a clash? Well, by default, last writer wins. That's a term we might hear in Cosmos quite a bit. So it's all about mindset. You know a lot about data, which is good, but think differently when you're going into the Cosmos world. It might get some surprises. And with Cosmos, we're going to scale out more databases, more servers, so to speak, rather than scaling up. So we're going to look at joins, normalization and T-SQL, consistency, and backup and restores. All things that are kind of fundamental to a SQL Server professional. So we'll flick over to a server. We look at a piece of JSON that we've got in front of us. Looks pretty self-explanatory. But the thing about this is it can be nested. It's different levels. So we don't have to have a schema that fits exactly all the time. We could put in a collection of JSON documents into here, and maybe they'd only have to have one thing in common, like the ID. We could have multiple nested nodes and carry on like that. We got containers. Now, we're used to joining in the SQL world. Well, joining containers in a Cosmos DB world can be very, very expensive. And I'm talking expensive in terms of money and not just resources. So there's a rough analogy between a container and a table. We store data in a container, we store data in a table. We think nothing of joining tables, but be careful when joining containers. It could bite you and lend you with a very, very expensive bill. So how would you get around that? You might duplicate your data. You might have one set of data in one container, and you might want a different kind of view of it in another container. So you would duplicate the data. It's your responsibility to keep it in sync. Now, consistency. In the world of T-SQL, we've got our recovery models. In Cosmos DB, we've got what we call consistency models. So on the one hand, we've got strong consistency, which is, if we've got multiple replicas around the world. Now, there's something that were multiple write replicas as well. It's not like one database is read-write, the other database is a read. We can have multiple write replicas around the world. Strong consistency is on one side. That means every replica around the world has to be consistent before anyone can see that data. And you might understand that if you've got a lot of models around the world, you've got a lot of latency, and that could lead to a lot of problems. On the other end of the scale, we've got eventual consistency, something that you might be familiar with in social media. I mean, if you post something on your social media, your friends that are close might see it straight away. Who cares if your friends over in the other side of the world don't see it for a minute, an hour, a day? So long as it's eventually consistent, that's all we really need. Microsoft make a default in the middle, kind of a halfway house between the two ends of the scale. And even between them, we've got other what we call consistency levels, bounded staleness that will, make things consistent within, like, say, maybe the last 10 minutes or the last hour, you choose. And at the other side, we've got consistent prefix going towards the eventual consistency. Now let's come to our last main point, which backup and restore, which is obviously bread and butter for any database administrator. Now, we're used to doing backup and restores on demand. There's no real way to, your backups will be done periodically, and they'll be saved for 8 hours. So you can do a backup, say, every 4 hours. So you've got 2 backups saved, and that is on a rolling timeline. Now, if you want to restore, you might be looking at me and going, oh, how do we got to restore? Well, you're going to have to pick up the phone and you're going to have to call Microsoft, provide them with a whole load of details and ask them for a restore. So you want to safeguard your data very, very well if you're looking at Cosmos DB. As I'm sure you can appreciate, if something goes wrong in, say, Australia, and you've got a model in America as well, that can be replicated over very quickly. So data can become not quite right very, very quickly. So you need to take that sort of thing into account. Lots of people have fell over with this. Hopefully you won't be one of them. So that was a bit of a whirlwind tour of Cosmos DB. I hope that maybe it has answered some questions for all you SQL gurus out there who know obviously SQL like the back of their hands, but maybe not Cosmos DB so well. So just in the last couple of seconds, I might point out some other things that might surprise you. Keys. A primary key, well, it's not what you expect. It's the first security key in Cosmos DB. So if you hear people talk about primary keys in Cosmos DB, they're not what you think. And an overloaded word in IT in general is containers, and containers store data in here. They're not the type of containers you might associate with things like AKS, Azure Container Instance, and the like. So I'll bring that to a close, and I hope you've enjoyed that. Look forward to the rest of the day, and have a great time. I'll now hand back over to William.